So I mentioned back at the beginning that we kind of had a section 0 that talked about the differences between ionic and covalent, and then we spent sections 1 through 4 on ionic bonding. Here, section 5 starts covalent bonding, which is that sharing of electrons that we talked about before. They call them molecular compounds. I'd call them covalent molecules. Similar thing. I will point out they use a different naming system, and there's a different way you have to come up with for figuring out the formulas. Molecular compounds are when two or more nonmetals share electrons and form a covalent bond, and they use that sharing to end up with a full outer shell. And it's called a molecule when they do that. When it comes to naming molecules, the first thing in the formula just gets its element name. The second thing, again, gets the beginning of it, and the suffix is "-ide". From there, if there's a 2 or more, then it absolutely has to have a numeric prefix in its name. The mono prefix is never used on the first thing. So you, for example, are familiar with carbon dioxide, and probably familiar, or have at least heard the name before, with carbon monoxide. I'll point out that carbon monoxide is toxic, and if you have an attached car garage, a wood-burning stove, or a fireplace, or gas heat in your home, you should have a carbon monoxide detector. They do save lives, and carbon monoxide is a colorless, odorless, tasteless gas that will make you very drowsy. You'll fall asleep, and then you don't wake up. Please protect yourself. Anyway, the name here, carbon, means there's at least a C there. Dioxide, well, that di, as you can see up here, means 2 oxygen. Notice we didn't use the mono prefix there. Mono is not used for the first thing, but if it's the second thing, it is used. And so that's the only weird rule when it comes to the numbering here. Carbon monoxide, carbon, and then 1 oxygen. If the first thing has more than 1, then we use a numeric prefix. For example, dihydrogen monoxide. Well, the di there means 2. Hydrogens. Monoxide. 1 oxygen. That's just water. There's all sorts of different ways you can actually chemically name water. Of course, we'd never call it dihydrogen monoxide unless we're just wanting to use it as an example like this. But we use a number on the first thing if it's anything other than a 1. We use the number on the second thing pretty much always. And I say it that way because it turns out that the new IUPAC rules, the group that's in charge of naming these things, has said, you know what, why not drop the mono prefix, because it's redundant and unnecessary. And I'm like, great, that sounds awesome. And then their rules also said, except for carbon monoxide, because it's become a common enough thing where we're going to confuse people if we just start calling it carbon oxide. So they let the mono prefix there. The problem is lots of textbooks, including ours, is out of date. And plenty of places have not adopted that rule yet, even though it's been what's formally approved and recommended going forward. So I don't care either way. I know if you're doing the homework on the computer, it is going to care, so use the mono on the second thing. Don't use the mono on the first thing. Anyway, over here we have then 2 different things where nitrogen can form, and unlike with using the charges, they don't have charges because they're sharing the electrons, they're not transferring the electrons, so these things have no charge. And so there's not really a way to predict how many oxygens nitrogen is going to bond to. We've done that experimentally, we've figured out how many it does, and then we know the properties of each of those gases, nitrogen dioxide and nitrogen trioxide. They also point out here that when the vowel of O or A appear together, then the first vowel is omitted. That is the vowel from the numeric prefixes, which I don't think I went over just a moment ago. So just to be clear, I'm sure you looked at them on the screen and saw them, but mono is 1, di is 2, tri is 3, 4 is tetra. I found that one weirds people out. They're used to thinking of tri, and the T just throws them, or they'll want to call it quad. Why isn't it quad? Well, it turns out that these are Greek prefixes, and quad is a Latin prefix, I believe. Anyway, I'll also point out that the game Tetris gets its name from the fact that all of the shapes in Tetris are made up of 4 blocks, and so That's where it comes from. Anyway, after that, we get into the ones that you're used to from your basic shapes. You've heard pentagon, hexagon, etc. Well, penta, hexa, maybe not the odd-numbered ones. They're not as commonly taught to little kids, but hepta, octa, nona, and deca. Anyway, when we have the double vowels there together, it's an A or an O. We drop them. The weird one is something like the I, and so one of my favorite compounds is actually nitrogen triiodide, and you have the double I there, which is just odd, and you may be like, why do you have a favorite compound? That's just weird. Well, yeah, I'm a chemist and a science teacher. I am a little weird. You have to be. But in addition to that, this is like the drop-it poppers that you can buy around the 4th of July, some other holidays where you just throw it on the ground and it goes bang, except it's way more sensitive. It's what's called a contact explosive, and it produces a purple cloud when it does go boom, so it's really cool. Anyway, and I just mentioned a moment ago that your textbook isn't up to date, and apparently I didn't read it carefully enough, because it is. And they say here that the prefix mono is usually omitted, as in nitrogen oxide. Again, trying to match these up here, although nitrogen monoxide is the older form of it and is still acceptable, with the exception of carbon monoxide, again, because it's kind of commonly known. Here are lists some more compounds and some of their uses. I encourage you pause, take a moment, and read it. I will say sulfur hexafluoride, it's only kind of used in electrical circuits. It's actually used to prevent arcing, to prevent sparks in electrical circuits, but it's really cool because it has the opposite effect of helium. If you breathe it in, it makes your voice go deep instead of high-pitched. Of course, both those were artificial. The downside is it's much harder to get it out of your lungs if you do breathe it in, and breathing in anything that's not air or oxygen can be dangerous, so please be careful if you do choose to suck helium balloons. Name this compound, just as doing some practice. So we have nitrogen, bromide, remember we changed that suffix, and then we need a numeric prefix on just the things that aren't one, so tribromide. Over here, I'm just going to name it, and then we'll figure out which choice it was. We have silicon, chloride, again, change that suffix, and then tetra for its prefix, so there we go. Here we actually have a number on the first thing, so diphosphorus, and then 5 there, so penta oxide, and actually I believe we dropped the A there, diphosphorus pentoxide, yes. Cl2O7, dichlorine, hept, and it's hepta, we dropped the A, so hept oxide. And so then, there we go. More practice over naming. This one is carbon monoxide. Again, the only one where the mono is absolutely necessary, although again, the double O, one of the O's gets dropped. Dinitrogen oxide. Dinitrogen monoxide would be acceptable. It's just not the proper way anymore. Phosphorus trifluoride, and carbon tetrachloride, which is partly responsible for new car smell. Diphosphorus pentoxide, I like to kind of do it like that, and then just remember that these become the subscripts, so P2O5, phosphorus pentachloride, PCl5, dinitrogen trioxide, N2O3, sulfur hexafluoride is the one I was just talking about, but SF6, so SF6. Now, that's great and all, but the problem is when it comes to actually looking at substances, you're going to have to be able to identify real quick, is this ionic or covalent? And from there, which naming system is being used. And the way you do that is you look at the first thing. And is the first thing a metal, like potassium, or a non-metal, like nitrogen? With your only exception being the polyatomic ion ammonium. If it's a metal, then it is almost certainly ionic, and if it is a nonmetal, it is almost certainly covalent. If it's ionic, the number does not enter the name, except charges on some metals. If it's covalent, the number does enter the name. And over here, they have a decent flowchart for figuring out. I will say there are branches, there are exceptions, there are some names that we've not covered here yet, and that's okay. But it is a good flowchart for trying to decide how to do it and when you need to use each naming system. I'd encourage you, again, practice with this at least. If you get to where you've got it locked down, then don't worry about it. Otherwise, your note card. So here, they want us to identify it as ionic or molecular. I'm going to use C for covalent, I for ionic there instead of molecular, and then name it. And so this one here is covalent, ionic, 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 and covalent. And again, we can identify that by what is the first thing. Is it a metal or a non-metal? And so all the ones here that are covalent are non-metals. All the ones that are ionic are metals, with the exception of this one down here where we have the ammonium, and the ammonium is a positive cation. If we want to be picky, ionics start out with the cation. Anyway, naming them then. If we do the two covalent ones, the first and the last one, this is sulfur trioxide, where the number enters the name. And this one here is dinitrogen tetroxide. All the others are ionic, and the numbers don't enter the name. So we have barium, chloride, and I'll point out that all of them end in "ide" unless there's a polyatomic ion. There's a couple polyatomic ions that do happen to end in "ide," hydroxide and cyanide. They're on your list. But beyond that, most of the polyatomic ions end in some other suffix, but the suffix has been changed for you already. Anyway, this one here is actually made up of two polyatomic ions. We have the ammonium ion, and then PO3 is the phosphite ion. Here we have a polyatomic ion in there, and so it's that piece there. And so we have copper. It's going to need a Roman numeral. And then CO3, that is the carbon 8 polyatomic ion. I'll switch ink colors here for the charge thing, since it's getting a little bit crowded, but carbonate has a 2 minus. There's one of them, so that gives us a total negative charge of 2 minus, so the total positive has to be 2 plus. That's split between two coppers, so then it's a 1 plus charge there. Roman numeral 1, copper 1, carbonate. You'll get plenty more practice over these, but that's the end of section 5.